right, good morning. Hopefully you'll be able to access this video. Having trouble uploading the videos from my mom's house, but it is what it is. So we are looking at page, well, this says 19, but I thought it was page 17 and 18. I do not have a current workbook with me, so I do apologize for that, but it is task number 8. So could be pages 17 and 18, could be page 19, but whatever it is, hopefully you'll figure that out. So here is the situation. We have a problem here at the top, and we have many different equations or linear functions that are describing that in some manner. And what we have to do is say, well, what's going on for this linear equation? Okay, so let me read the problem number 1. A student has had a collection of baseball cards for several years. Suppose that B, the number of cards in the collection, can be described as a function of T, which is the time in years since the collection was started. Explain what each of the following equations would tell us about in terms of the number of cards in the collection over time. So this is essentially the same as slope-intercept form, which is y equals mx plus b, okay, where your y value is going to be the capital B, the number of cards in the collection, is equal to, in this case, we have some number which varies times T, and then plus some other constant. Okay, so the total number of cards in the collection is equal to a function of T, something's happening over time, plus some constant which is happening. If you're thinking about the y-intercept, it is when x is equal, or in this case, t is equal to 0. So it would be at the very beginning of that collection. Okay? So let's take a look. Problem A, let's focus just on A, says the number of cards that I have is equal to 200 plus over time, which is in terms of years, that's good to understand, plus 100t. Okay, so again, as I look at this, this is like y is equal to the mx over here plus the y-intercept of b. Okay, so this 200 represents and says that in this collection of cards, we have 200 cards that this person had. I don't think they gave a name. Oh, it says a student. Okay, so the student started with 200 cards, and then over time, and time is in terms of years, he added to that collection 100 cards per T number of years. Okay, so describing this situation would be that the student starts with 200 cards in his collection, his or her collection, and again, that's the y-intercept. That means where, oh great, where x is equal to 0, this 200 would be on the y-axis. And you cannot see this, but it says that it's saving my notebook. So I'm not able to write it this time until it stops saving my notebook. And hopefully this will go through. There we go. So the student starts with 200 cards in his or her collection and adds, because of this plus sign, and adds or gains 100 more cards each year. Okay, we get all of that basically from this linear equation. Let's take a look at the second one. Letter B. So the number of cards in the collection is equal to 100 plus 200 times t, where t is our number of years. So very similar to the first one with slightly different numbers. All right, so this would be that a student begins with 100 cards, and we're talking, was it baseball cards? I think it was baseball cards. 100 cards in his or her collection. And here's my plus sign, gains 200 more, well, come on, 200 more baseball cards each year. All right, so similar but with different numbers. All right, let's take a look at letter C. Here, our linear equation, y equals mx plus b. Here's my y equals, here's the y-intercept b. And here it says instead of mx, it is a negative mx, okay? So this would be the plus the negative mx. It's still mx plus b, but it's a negative amount. So what is going on here? Oh, I had another one in some notes. Not sure what's going on here. But I guess I can start talking my way through it, and hopefully by the time I get there, maybe it'll let me write. So B is the number of cards in the collection, is equal to, so at the beginning of this time, in this equation, so the number of cards in the baseball card collection is equal to 2,000. So this student has 2,000 cards, and instead of gaining 100 each year, this person is somehow losing them. And how would you lose baseball cards? I mean, you could literally lose them, but that's not very likely. Yeah, I knew that was going to happen. I said error. But perhaps maybe they are giving away or selling off 100 cards each year, okay? So that if they maintain this same linear function, then at some point they will get down to 0. So, there it came clear. So, a student has 2,000, I want to make sure this is baseball, right? Yes. A student has 2,000 baseball cards. In their collection. And every year, he or she, you could say, sells or gives away 100 of their baseball cards. So that is what is going on in this particular linear equation. Okay? So we have three different stories to each of these problems, which have slightly different numbers. And let's take a look at the last one. So in the student's collection, they have 100 cards to begin with, and they decide to give away or donate 200 cards per year. So a student has a baseball collection, baseball card collection of 100 cards. Every year, the student donates or sells 200 baseball cards. Okay, that is literally what this equation is saying. So the student has a baseball card collection of 100 cards, that's your y-intercept, and every year the student donates or sells 200 of those baseball cards. Now, if you really get to thinking about this, it doesn't make much sense because the student only started with 100 baseball cards. So as an addendum, we probably should say, oh, I wanted that in blue. This example does not make sense in the real world. So mathematical equations here can be written in many different ways, but only and sometimes will they make sense in the real world. And letter D for this situation that was given to us and set up does not make sense with this word problem. Okay. All right. Number 2 says, which one of the following could be modeled by y equals 2x plus 5? So this is, again, a linear equation. Y equals mx plus 5. Answer yes or no for each one, and then if it does not seem to match, then can we write a new one? So letter A says, there are initially 5 rabbits on the farm. Each month thereafter, the number of rabbits is 2 times the number in the month before. Okay, seems okay. There are initially 5 rabbits, so the number of rabbits is equal to 5 plus, says twice the number of rabbits than in the month before. So I could see twice the number of rabbits but X is like over time. So let's see if that might work. And again, I've got that saving notebook. So I can't write at this time. So my X value is going to be the number of months that happen. Oh, come on. Yes, saving notebook. Saving notebook. I'm glad you're saving the notebook. All right, here we go. So X is equal to the number of months. That is your time. That is your independent variable. And Y is equal to the number of rabbits. Okay. So as I set this up, as 1 month goes by, according to this equation, as 1 month goes by, well, first of all, let's go to 0 months. 0 months, if I substitute 0 in for X, then I would have 5 rabbits. And after 1 month, 2 times 1 would be 2, plus 5 would be 7. So this I'm going by way of the equation. And if I substitute 2 in for my equation, I get 2 times 2, which is 4, plus 5 is 9. And I could put in 3, 6 plus 5 is 11. Okay. So then it says, looking back, there are initially 5 rabbits on the farm. Okay, initially, I do have that. Each month thereafter, the number of rabbits is 2 times the number than the month before. Okay, so as I look, and the next one I get is 7 to follow along with my equation. That is not 2 times my previous month, which was 5. That would have given me 10. So 7 is not twice as big as 5, and 9 is not twice as big. So the wording here in my problem does not follow along with this model. So that means this is a no. All right, so that is not a linear equation. Okay, so Joaquin earns $2 for each magazine sale. Each time he sells a magazine, he also gets a $5 tip. Okay, so how much money will he earn after selling X number of magazines? Okay, X is, in this case, going to be the number of magazine sales and Y is supposed to be 2X plus 5. Okay, so let's see. $2 for each magazine sale he gets. Every time he sells a magazine, he also gets a $5 tip. So in that case, Y, what we're talking about here, so he gets $2 for each magazine sale, and it says he also gets a $5 tip for each magazine sale. So that would be plus $5 for every number of sale that he is. If X is the number of magazine sales, 2X plus 5X would be that Y is equal to 7X. And that also does not seem to follow along with this linear equation. That would imply a one-time, like $5 bonus one time, not $5 for each of the number of magazine sales that he sold. So that is a big no. All right, letter C. Sandy charges $2 an hour for babysitting. Parents are then charged $5 if they arrive home later than scheduled. Assuming that the parents arrive late, how much money does she earn for X number of hours? Okay. So $2 an hour, X is equal to the number of hours that she babysits. And then assuming they arrive late, she charges $5. That $5 is one-time fee. It doesn't happen all the time. So 2 times the number of hours that she babysits plus $5 for the one-time fee. We're assuming they arrived late. Then yes, this is going to work for our equation y equals 2x plus b. 2x plus 5. Okay. Let's take a look at the next one, D, E, and F, and these should be the last one. I have a sequence of integers. The first sequence is 7, and the difference between any consecutive numbers is always equal to 2. All right, the first term is 7, and the difference between any consecutive numbers is 2. Let's go back. Sequence of integers. The first term is 7. The difference between the consecutives is 2. All right, so we have X and Y. X is going to be the independent variable and the first term of the sequence. So whether you're the first term or the second term or the third term does not determine anything. So that is the number of the term of the sequence. And it says the first term is a 7. So the y is the number selected. So the first term is 7, first term, and the difference between any consecutive terms is always equal to 2. The difference between would be 2. So that would mean that the next term would be 2 higher, the next term would be 2 higher than that, the next term would be 2 higher than that. So if I said y equals mx plus b, then y is equal to 2x plus 5. So if I substitute 1 in here for x as my first term, 2 times 1 is 2 plus 5 is 7. That seems to work out. If I select the second term, 2 times the second term is 4 plus 5 is 9. 2 times the third term is 6 plus 5 is 11. 2 times the fourth term, and that looks like it's going to go all the way through. That one was a lot more tricky. If you got that one, I'm impressed. All right, let's take a look at letter E. Sneak Preview is a members-only video rental store. There is a $2 initiation fee and a $5 per video rental fee. How much would John owe on his first visit if he becomes a member and rents X number of videos? So $2 initiation fee, that is a one-time fee, and then $5 per video. That seems to me a $2 fee and would be plus $5 per video, where X is the number of videos and Y is your total cost. Okay, so it's similar, it's got the same numbers, but the y-intercept and the slope are reversed. So that is going to be a no. And the final one, Andy is saving money for a new CD player. He began saving with a $5 gift and will continue to save $2 each week. How much money will they have saved at the end of X number of weeks? So y equals mx plus 4, plus 4, mx plus b. And so y is equal to, he's going to save $2 each week. So when you're putting in the slope, that's happening repetitively. So my slope here is 2. He's increasing that amount that he's putting away for X number of weeks. Plus he started out with an initial $5. That definitely looks like that is a yes. Okay. All right. 3, we are not going to do 3 at this time. So, looks like you could start on homework 3, but I am really interested in making sure that you are working on this topic 4, module 4, and I really want you to be working on homework 1 and 2 to get those done by Friday. Okay, thanks for your patience through all of this, and hopefully you are following along and getting some of these correct. I will see you with another video tomorrow. Bye-bye.